Hello and welcome back to the CCNA journey with me, Ryan, and this will be part 2 of the OSI model, focusing on the upper layers. For those who don't know, you can contact me here on YouTube, Facebook, Twitter, or you can connect on LinkedIn. If this video series has been helpful, please do like and subscribe. And it's also worth noting that this video was pre-recorded for the CCNT or the ICND1 and is being reused for this new CCNA course because the content of the OSI model is still relevant and required in order to pass your CCNA. Okay, let's get started. Okay, so here we are. We've got the overview of the Open System Interconnect model, which is the OSI. And we're going to start at layer 7 and work our way down, discussing each layer in a little bit more detail to give you an understanding. Once we've discussed it and we understand what each layer of the OSI model actually does and briefly how it interacts with the layer above, below, which is referred to as adjacent layers, what we'll then do is have a discussion around the encapsulation and decapsulation process. That may be in this video, but it will most likely be in the next, because I'm sure that this video will take up a lot of time going through the Open System Interconnect model. So starting with the application layer then, what is it? Essentially, it provides the initial network connection for user applications, and it allows the applications to connect into the network. This is where your end users actually sit. So we previously discussed this concept of networking applications, and we agreed that a networking application is an application that uses some protocol. In this case, let's say for example, HTTP or SMTP, to interact with the network. So we said a browser is a good example of a networking application. Whether that's a Firefox, Chrome, Safari or IE, essentially it uses a protocol. In this case, well, in this example, let's say it's HTTP, the Hypertext Transfer Protocol, and it uses that to interact with the network. We also said that there are many other networking applications like email clients, and email clients may use protocols like the Simple Mail Transfer Protocol, SMTP, to send emails. It may also use things like POP3, the Post Office Protocol, to receive emails, or IMAP, for example. Regardless of what it is, we all agreed that the networking application is an application that interacts with the network, and therefore those networking applications sit at layer 7. What we also said was there are certain applications that do not require networking interaction. Applications like Notepad and Paint. And those type of applications do not sit at layer 7 of the OSI model. Further to this, we then had a brief discussion about presentation. Now, presentation is a very simple one. When we think about presentation, what we need to think about is how to present the data. Now, we also had with this term, last video, called upper layers and lower layers. And we said that anything in these three layers here are referred to as the upper layer, and anything here is referred to as the lower layer. Now, essentially, as network engineers, we primarily focus on the transport, network, data link, and physical. And there's no way ultimately as a network engineer to control what happens at the session, presentation, and application. All we need to be aware of is what's actually happening there and what are the responsibilities of those layers. So we know the application layer is where the users interact. The presentation layer is how the application layer actually presents the data. So maybe we have a HTTP protocol interacting and requesting a HTML page, and in that HTML page, maybe it uses ASCII, or maybe it's got pictures in there, so it's a JPEG, and it pulls down those ones and zeros from a remote web server. And ultimately, the presentation ensures that the information that is pulled is able to be presented both when it's received at this end and when it's requested at the other end. This is also where two very important elements sit. This is where compression and encryption also sits. Again, if we think about compression and encryption, it changes the way the data is presented when two hosts receive traffic from one another. Okay, so moving further down the stack, we come against the session layer. The session layer is layer 5, and quite a few things here happens at the session layer. The session layer helps establish sessions with reserved ports, helps track connections between remote host, and it also allows us to negotiate some duplex with the remote host. So to give you an example, let's say we have our PC, and our PC is communicating with a remote server, and they're going to be using the hypertext transfer protocol because this is ultimately a web server. And on this PC, he has we have our favorite web browser open, and we have tab 1 and we have tab 2. Now in this kind of scenario, there's actually a few things the session layer at layer 5 helps us with. The first thing it does is a duplex negotiation with the remote host. The remote host in this sense happens to be a web server. It could have been another PC. And essentially what happens is it negotiates to see whether the communication flow can either be full or whether it be half. Full allows you to send and receive data. Half allows you to send or receive data, not both at the same time. Once it negotiates the duplex settings, and let's say for example it agrees on full, what the session layer also does is it puts unique port numbers or unique source port numbers against every session to a remote host. Now this actual unique port number is actually a bit of a weird name. It's called a ephemeral port, and that's not an R there, that's actually an M. So that's EPHEMERAL, an ephemeral port. And essentially an ephemeral port is a randomly generated port number between a particular range to allow a remote server to keep the sessions coming in from your particular IP unique. Now, what we'll do is we'll discuss this a bit more when we talk about transport, but essentially the session layer reserves what ports to be used and give those reports downstream to the transport layer, and the transport layer populates its PDU, its header, with the ports that the session layer supplies it. Let's say, for example, these two tabs up here, one may get 3333 as a ephemeral port, and the other one may get 33344. Maybe it might even get 60,344. It's just a random number between, I think it's between 1,024 and up to 65,300 and something. I think it's probably 35 or 65, but ultimately it's a random port within this range. The reason it's not up to 1024 is because 1 to 1024 is something called the well-known ports. And some of these ports, which I'll get to in a moment on the transport layer, are port numbers that you have to remember. Like for HTTP, we know it's port 80, SMTP, port 25, POP, port 110, and so forth. But ultimately, the session layer assigns unique ports to each session that you have. So when the receiving host receives your data, it knows what port to send it back to in order to make sure that the sessions are not overlapping or bleeding between one another. So as you can see, the session layer is obviously just as important as any other layer. Okay, so moving further down the stack to layer 4, this is our transport layer. This is the first lower layer that we're going to discuss, because we've now finished discussing the upper layers. Now, at the transport layer, there are two protocols that are mainly used, which is the transmission control protocol and the user datagram protocol. And we'll have a separate video discussing the differences between those. But very high level, TCP is something that allows us to have message acknowledgement, message segmentation, allows us to essentially deliver traffic error-free in sequence with no loss or duplication. UDP, on the other hand, is very much shove it out the front door, and hopefully it's received by the remote host. There's no error correcting there, there's no retransmission, and there's no tracking of information. And we'll come to actually understanding the differences between them and why you may use one over the other. What also happens at the transport layer is, as I previously just mentioned, this is where the session layer populates the transport layer's PDU with port numbers. Okay, so we have to think about where we are at the moment. We have data. The data was given to us from the application layer, and as part of the application layer, it identified how that data should be presented and what ports to use, both the destination and the source port, and the source port being that ephemeral port. It gives it down to the transport layer. The transport layer PDU comes on, and depending on the application, it may choose to use TCP or it may choose to use UDP. Let's say in this case, it's decided to use TCP. The session layer will give us the source port number. Let's say that's 60,311, and the destination port number, let's say that's 80. Because we're using TCP, we know that the information is going to be reliable. It's going to get there, and if it doesn't get there, it's going to be retransmitted, and there's going to be what's called a three-way handshake with a remote host. And the three-way handshake is essentially, before a host sends traffic to another host, and using TCP, it does a three-way handshake where the host sends what's called a sync. The remote host sends a sync ACK, and then this guy sends an ACK back to say, I've received your sync ACK. And then these two devices, whether they're on the same segment or whether they're multiple networks away, is able to communicate with one another to ensure that the sequencing of traffic is correct, and any traffic that's missing is able to resend and essentially correct any errors that may have happened along the path, whether maybe a router's dropped it because it was too busy or buffer was full. Wherever it may be, TCP adds that layer of essentially of reliability, which is why it's initially called a connection orientated protocol rather than its partner in crime, if you like, which is a connectionless protocol, which does not go through this handshake process, and in fact just completely sends the UDPs or the traffic, if you like, directly to the remote host without any reliability or without any error correcting or flow control. And there are some reasons why we might want to use one over the other, and as I said, we'll come on to that as we get through our video series. But for now, we know our data, and we know that this particular example is using TCP and Transmission Control Protocol. We know the ephemeral port that the session layer has given us, and we also know the destination port. I said to you previously that there's these things called the well-known ports. These well-known ports are things like port 80 being HTTP, 25 for the Simple Mail Transfer Protocol, SMTP, and other things like 110 being POP, 23 which is telnet, 443 which is HTTPS, and a few others. And depending on what reading material you'll go through, there'll be a list most likely of 10 or probably more ports that you have to actually remember, and you will have to remember them. There is no way around it. And you will not only just remember the name of the ports, but you'd have to remember what protocol that layer 4 actually uses. So HTTP, SMTP, POP, telnet, HTTPS all use TCP, whereas things like DNS primarily uses UDP, but in some instances can use TCP. So you need to know most of the, I wouldn't say most of the well-known ports because there's 1,024 of them, but most that I've outlined in the actual book that you're going through. So make sure you put them down, maybe have them on flashcards or something, so it helps you through learning all that information. Okay, what I want to do is actually just end the lesson there. The reason I want to end it there is because the OSI model is a big chunk of the CCN, and it's extremely important that you understand it in depth. So what I don't want to do is have a long, laborious video. I want to cut that up so it's easier to digest. In this particular video, we took base on the application layer. We understand that this is where our end users interact with the network or interact with the OSI stack. We had a discussion around networking applications and what they actually are and what are not networking applications, things like Paint and Notepad. We then moved on to the presentation layer, and we explained that the presentation layer is how the information should be presented. So we talked about things like compression working here and decryption. Anything that would essentially modify the way the information should be perceived. We also said things like ASCII and JPEG work at the presentation layer. We then went on to the session layer. We had a brief discussion around why the session layer is so important and how it actually does the negotiation of Duplex with a remote host, and how it uses the ephemeral ports and destination ports to keep the sessions separate, and how it also pulls that information downstream and gives it to the transport layer in order to populate its PDU with the port numbers that are required. And then we finished up talking about the transport layer. We had a very, very brief overview of what is TCP and what is UDP, why you may use one over the other. As I said, there'll be more videos to come on just the transport layer itself because it's so big, as well as the layers to come. So all the lower layers will have obviously more information than the upper layers. In our next video, we're going to continue with the open system interconnect model, and we're going to finish up with understanding the network, data link, and physical layers. Last but not least, I'd like to thank you for watching, and I hope this video has been informative. And if it has been, please do like and subscribe.